Hi, welcome back to the Quick Maths channel. Today we'll be tackling the SBP 2020 Paper 1 question for additional mathematics. So if you guys would like to hear any further explanation or have any questions for my method of work, please let me know in the comments or email me. My email is down below. And also I have set timestamps for all 25 questions in this paper. So if you guys would like to see a particular question, please click on the timestamp. And also if you guys would like to attempt the question first, I recommend you guys to pause the video because I will be going straight through the solutions, so there will be almost no delay between the questions. So if you guys would like to attempt the question, please pause the video and then you can see the solution immediately after. So without further ado, let's get started. So we have question number 1, form a quadratic equation with roots a and 2a. Give your answer in general form. So first of all, give our answer in general form. We have the general form of the equation where we say that ax squared plus bx plus c is equals to 0. So from here we have, this is the general form that we're trying to achieve, right? And furthermore, in order to create equation from roots, we have another formula where we say that x squared minus SORx plus POR equals to 0. Right? So as long as we know what is SOR and POR, where they are the sum of roots and product of roots respectively, we will be able to develop a quadratic equation in this case. So from here we have the roots given to us as a and 2 over a, and from here they ask us to then we can work on the SOR and POR. So for the SOR is a plus 2 over a. So since we know this is a over 1, we can multiply the denominator and numerator by a so that we can get a squared over a plus 2 over a, and we can immediately move to a squared plus 2 over a in this case. So we are done with the SOR, whereas for the POR is a multiplied with 2 over a, and these two can cancel out, so we have 2 at the end. So from here we have x squared minus SOR, which is a squared plus 2 over a, x plus POR, which is 2, which is equals to 0. So we have applied this formula already. Now to change it to general form, we need to get rid of the fraction here. So we are going to multiply all the terms here by a. So it's times a, and times a. So we're going to get ax squared minus a squared plus 2 x plus 2a equals to 0. And this will be our final answer here. So moving on to question number 2. So a group of 150 students was selected to complete a science project. So in a certain number of weeks, on the second week 4 students withdrew from the project. The next following week another 4 students quit, and so on. Find the number of weeks in which the work was completed when there were only 22 students left. So this is actually an arithmetic progression, or we call it AP, because we know that you started off with 150 students, and from this 4 students leave every week. So we can see that the progression, we can find a common difference as -4 here because they leave. So they finished the project when there were 22 students left, right? So we do not know what position this is, but we know that we can just denote it as Tn. So since we have Tn already, we have the formula for arithmetic progression where we say Tn is equals to a plus n minus 1d, right? So we know what is the Tn, we know what's the a, and we know what's the d. We can solve for the n, which is the position. So we can just put in the formula here. Then Tn is 22, a is 150, n is unknown, and d is -4, right? I should write d -4 here just for clarity. So 22 equals to 150 plus, in this case minus 4n plus 4. So it will be 22 equals to 154 minus 4n. So it will be 4n equals to 154 minus 22, and we make 132 here, make n the subject, so we have 132 divided by 4, that is 33. Right? So it takes 33 weeks for them to complete the project in this case. So question number 3. So it is given that 1m squared and m4 are 3 consecutive terms of a geometric progression. So find the sum to infinity of the progressions in terms of m. I just realized that I think putting the camera in this position is actually a bit better, because I just realized that I'll be blocking the first two questions. So apologies for that. So for these questions onwards, I will put the camera in the bottom right. So it is given, yep. So our 3 consecutive terms of a geometric progression. So find the sum of infinity. So we have the geometric progression as 1, m squared, and m power 4. So since we know that this is a geometric progression, we can find the r, or the common ratio, where we can take t2 over t1, or we can take t3 over t2. It's up to you. So I'm gonna take t2 over t1 for simplicity. So it's m squared over 1. So from here it will be m squared, just m squared. So they ask us to find the sum of infinity. So the formula for sum of infinity is a over 1 minus r. So we have 1 over 1 minus m squared. This is done. Yeah, just like that. Alright, so for question 4, the curve y equals to fx is such that d squared y dx squared is 18x, dy dx is 13, and y is 11, x is 1. Right? So we are given a few quantities to work with here. Right? So we will be, to find the equation of the curve, we basically need to use integration. We need to work backwards from the differentiation. So we do not start from dy dx, because dy dx here is actually the gradient already. It's no longer a gradient function because there's no more unknown on the, it is just a constant at this point already. It's gradient. So we have to start from an equation that actually gives us an unknown to work with. So we're going to start with the second derivative here. So from here, if we integrate d squared y dx squared, we end up with dy dx. So integrating 18x will be 18x squared over 2 plus c. So we have a c here because we have no limits for integration, as this is an indefinite integral. So from here we have dy dx equals to 9x squared plus c. So we are given the value of dy dx and we are given the value of x, so we can sub it in. Dy dx equals 13, x equals to 1, therefore 13 equals to a 1 square plus, sorry, it's not a, 9. So 13 equals to 9 plus c, so c is equals to 4. So since you know c is 4, we have dy dx equals to 9x squared plus 4. So once again, we're going to integrate the equation. So it will be y equals to 9x cubed over 3 plus 4x plus c. So just making it a bit simpler, dividing by 3. So we are given these two equations here. So sorry, these two values here, where x equals to 1, y equals to 11. So 11 equals to 3, 1 power 3 plus 4 times 1 plus c. So we end up with 11 equals to 3 plus 4 plus c, 11 equals 7 plus c, and we know that c is equals to 4 once again. Therefore, the equation of the curve is y is equals to 3x cubed plus 4x plus 4. And this is solved. Right. So for question number 5, it is given that diagram 1 shows two curves, y equals hx, and we know that the y equals gx, and the tangent to each curve when x is equals to 0. Right, so when x equals 0, that means they are basically giving us the y-intercepts here lah. So these are the y-intercepts, where c and negative c. So the two tangent lines are parallel, and gradient of the line y equals gx at point P is 1. So since they are parallel, means the gradient here is 1, the gradient here is 1 as well. Okay, so it is given that fx equals to hx over gx, find f prime 0. So they ask us to find what's f prime 0. So before that, we should find out what is f prime x first. So we know that fx equals to hx over gx, mistake. So f prime x means I'm actually differentiating the equation. So to get the differentiation, we have to use the quotient rule for this, where the quotient rule is given as dy dx equals to v du dx minus u dv dx over v square. So we usually assume that u is on the top, v is at the bottom. We usually assume like this, so we can differentiate like that. So from here, we are going to assume the u as hx, and when we differentiate u, we will get h prime x, right? And whereas for b, when we differentiate v, we are going to get g prime x, right? So applying the formula, f prime x would simply be v du dx minus u dv dx over v square, right? So this seems a bit gibberish at this moment, but don't worry. They ask us to find what is f prime 0. So with f prime 0, right, because the initial is f prime x, right? So f prime 0 means when x is equals to 0, right? So that's a very important clue that they provided to us. So when I put f prime 0, I'm just going to insert 0 to every single term here. Just going to replace all the x with 0 at this point. So g prime 0 over g0 square. Now we look back at the curve. So when g0 means g0 means x equals 0. So when x equals 0, we are actually referring to the y-intercepts here. So the equation y equals gx is here. So when g is 0, we know that it is c in this case, because this is the y-intercept, right? So again, g is the y-intercept. So h prime 0 in this case would be when x equals 0, what is the gradient, right? Because remember, h prime x, g prime x, and f prime x, all three of these things are gradient functions. So because they are gradient functions means if you insert a value of x in them, you find the gradient at that point. So when x equals 0, they said the gradient is 1 already. So from here we can say that this is just 1. So again, h0 here is the y-intercept once again, but for this time for the hx graph, so this is negative c. G prime 0 is 1 once again because they are parallel. So over, so g0 like we mentioned earlier is c. This time we are going to square it, right? So just going to erase this because I need a bit of the space. So from here, it will be c minus or plus c over c square. So it is 2c over c square. So simplifying it would be 2 over c. And this is our final answer. Right. So moving on to question number 6. So the function a is defined by a equals to half x squared, x plus 2. So function, find dA over dx. So we're going to have to just differentiate this equation. So we have a is equals to half x squared, x plus 2. So just going to multiply, expand the brackets first. So it'll be half x cubed plus half x squared times 2 is just x squared lah. So d8 over dx, differentiating the equation, we have 3 over 2 x squared plus 2x. Right, so this is done for question number A, for question A. So question B, determine the approximate change in A when x changes by percent of 2. Right, so we are doing an approximate change. So an approximate change formula means delta A over delta x is approximately equals to dA over dx in this case. So delta A delta x, delta A delta x represents what we call as small change, right? dA dx is the original value here. So by applying the small change to the original value, we will see the changed value in the end of the day. So in this case, what we have been given in the question is that we have been given the original value of x, which is 2. And we are also given the delta x, right? So the delta x is p% of 2, means x changed by p%. So p% is basically p over 100 times 2. That is a p%. So it is 0.02p in this case, right? And aside from that, we do not know what is our delta A, right? So, but from our first question, we know what is dA dx. So by applying the formula now, we have delta A over delta x equals to dA dx. So delta A is unknown, delta x is 0.02p, and dA dx is 3 over 2x squared plus 2x. So we know that x original is 2, so we say when x equals to 2, delta A over 0.02p equals to 3 over 2, 2 squared plus 2 times 2. So delta A over 0.02p is equals to, let's count, 3 over 2 times 4 plus 4. So it equals to 10. So in this case, we know that the approximate change of A is simply 0.2p when we cross multiply. And this question is done. So moving on to question 7. So for question 7, it is given kx is a function such that x equals to 7 plus kx over 3 minus kx. So find k inverse 2. Now, interestingly enough, right, when we look at this equation here, this is actually the inverse. This is actually the equation for the inverse of k already. Now, if you don't believe me, let's look at let's use a sample function. So for example, let's say fx equals to say x plus 1 over x minus 1. So usually when we want to inverse a function like this, we will let y to the equation. So let y equals to x plus 1 over x minus 1. And then we solve the equation and make x a subject in this case. So I'm just going to rearrange it slowly. So it'll be x y minus 1 over 2 equals to 2, sorry. So it will be x equals to 2 over y minus 1. So you notice what happens here is that what I've been doing right now is just, oh sorry, this is supposed to be y. So 1 plus y. So this is supposed to be 1 plus y. So x equals to 1 plus y over y minus 1. So you see what happens here is that when I said let y equals x plus 1, essentially it is just fx, but I'm just using y as a placeholder. So if I put fx into the equation, it will be x equals to 1 plus fx minus 1. So you notice how I'm actually, the way that I do the inverse, I end up with something like this by making x a subject. So from here we already know that this is the inverse of k. So I can simply say that k inverse x is equals to 7 plus x over 3 minus x. So from here straight away, I can do k inverse 2, which is equal to 7 plus 2 over 3 minus 2, and my final answer is 9 over 1, which is just 9. Right? So there is no harm in finding out the function of k first, right? Like if you want to expand it, like you want to make k the subject, so you're gonna get 3x. If let's say you do make k the subject in this case, so you end up with 3x minus xkx equals to 7 plus kx, and then 3x minus 7 equals to kx plus xkx. So we have 3x minus 7 equals to kx 1 plus x. Right, you can find kx first, your choice, and then you can inverse the function. But you notice that when you inverse the function, you will end up with what the question actually provided with you once you try. So actually, we are saving a lot of time here. This is actually a very short question, right? So as long as you know the concept for this, we can straight away apply this as the inverse in this case. So this is question 7 done. So moving on to question 8. So for question 8, we have given a function fx equals to mx minus 5 and f squared x is 36x plus 25, where m is a constant, m is less than 0. Express f3 in terms of m. So we are going to just use f3 instantly. So f3 equals to m3 minus 5. Whatever happens to the x here happens to the x here. So from here we have, oh, that was a glitch. So we'll have 3m minus 5, and that's done for A. So question B, we have find the value of m. So we were given a function of f square x. So f square x is 36x plus 25. So f square is essentially ffx equals to 36x plus 25. So f, we know fx is mx minus 5 equals to 36x plus 25. So f mx minus 5 in this case is that this is originally supposed to look like this, right? Now x is being replaced by this. So like I mentioned earlier, whatever happens to x will happen to that function. So if you look at it properly, let's say fx equals to 2x plus 1. If I call it fp, this will become 2p. If I call it fg, this will be called 2g. And if I call it fg plus 1, it will be 2g plus 1 plus 1. So whatever happens here, happens here. So in this case, now x is now mx minus 5. So this is going to go inside, oops, sorry. This is going to go inside here, in this case. So to make that happen, we are going to have mx minus 5 equals to 36x plus 25. So we have m square x minus 5m minus 5 equals to 36x plus 25. So at this point, we can actually compare either between this and this or this and this. It is your choice. So why we can compare them is because this term in the boxes here is we are comparing the coefficients of x, because this is m square x where the coefficient is m square, and this is 36x where the coefficient is 36. So if you compare them, you will get m square x equals to 36 over 36x. You can drop the x, you'll be m square equals 36. And if you square root both sides, we have m equals to plus minus 6. So since they already mentioned that m is less than 0, therefore m is equals to negative 6 in this case. So this is question 8 done. So for question 9, so given some integers here, v and k are positive, so find the range of k if the mode is 6. So if the mode is 6, means k can't be 6 at this point because the mode is already 6. So k has to be less than 6. So we can say that k is less than 6, but also k can't be 0. So but it can be greater than equals to 1 in this case, right? So yeah, that's about it for because also because k is a positive integer and 0 is usually not considered. It's kind of like it's kind of like 0 is neither positive or negative. It's more of a neutral number. So in this case, we say that k is between 1 and 6 lah, but must be less than 6. So this is A. So question B. So assume that k is 7, sure. So express the median in terms of v, right? So now if we assume that k is 7, means that our total data now, so this is the f here frequency, 5, 3, 6, 7, 2 and 5. So our summation f, or our total frequency in this case, is 5 plus 3 plus 6 plus 7 plus 2 plus 5, that is 28. So since we know the total amount of data we have is 28, the median is the part in the middle of the data. So if we take 28 divided by 2, we will get 14, right? So 14 is not the middle of the data, but it represents where the middle of the data is actually is. So if you look at the data, the first 14 data is on this side. So the first, second, all the way until the 14 is on one side, whereas the 15th all the way until the 28th is on the other side. How we know this is because there are 14 pieces of data here and 14 pieces of data here, right? So the median is actually between the 14th and the 15th data. So given that the 14th data, in this case, if we count it cumulatively, this is the first to 5th data, this is the until the 8th data, and this is until the 14th data, and then from here this is until the 21st data, 23rd data, 28th data. So at this point here, we know the 14th data is 6, so we can say that this is 6, and the 15th data here is 2v plus 2, and the median is between those two datas. So that's why we can say that the median is 6 plus 2v plus 2 over 2. So in this case, it is just 4 plus v. So this is our median. Right, so this is for part 1. So part 2, now they ask us to find the value of V. So to find the value of V, we need to understand that these numbers are arranged in ascending order, right? So they are ordered in a specific manner. So if you look at the numbers here, we have 1, 2V minus 1, 6, 2V plus 2. Maybe I should write it a bit lower. Maybe I should write it towards the right side lah, in this case. So here, so 1, 2V minus 1. Actually no, I can just write it on top. What am I doing? I'll just use the stuff on top. Yeah, I'll use the stuff here, right? So you want to refer to the previous question, just look at it, yeah? This is not really relevant to it, so I can just erase this. So let's make a few assumptions here. Let's say when V equals to 0. If V equals to 0, our data is now going to be 1, -1, 6, 2, 10, and 12. So this doesn't make sense because obviously this is not in ascending order. This is a random assortment of numbers at this point. So V equals 0 is not able. We are not able to use this. So we try V equals to 1. So when V equals to 1, we have 1, 1, 6. This is 2 times 1 plus 2 is 4, 10, 12. Once again, it is not in ascending order. So we try V equals to 2 again. So when V equals to 2, we have 1, 3, 6. So 2 times 2 plus 2 is 6, 10, and 12. So once again, not proper because these two are supposed to be different numbers. So V equals 2 is also out. So we have finally when V equals to 3. So when V equals to 3, we have 1, 2 times 3 is 6, 6 minus 1 is 5, 6, 2 times 3 is 6, plus 2 is 8, 10, and 12. So in this case, V equals to 3 fits this criteria. So we can just stop at V equals to 3. You can attempt V equals to 4, but definitely this is wrong because it's going to be, this is definitely going to be smaller. This is definitely going to cause the numbers to be out of order in this case. So we ignore this. So we move on to question number 10. So question number 10, find a set of, given a set of data as follows. Find the first quartile. So before we start with any first quartile, third quartile nonsense, we usually start with the arranging of the numbers in ascending order, right? So from there, we will find the middle point of the data. So between the data, the median is actually between the third and the fourth data here. So your median is somewhere around here. So your first quartile and your third quartile exists on the left side and right side of the data respectively. So the Q1 is essentially just the middle of the first half of data, whereas the Q3 is the middle of the second half. Right? So in this case, Q1 very easily found, where Q1 is just 3 lah. So from here we can just say Q1 equals to 3 for question A. So for question B, if each value of the data is multiplied by 5 and 10 is added to it, find the new first quartile. So if you were to do it, you notice that the position doesn't change. The values increase, but the position doesn't change. So all you need to do from here is just 3 multiplied by 5 added by 10. So the answer is just 25 here. And this is done. 2 mark question, doesn't take too much work, thankfully. So question 11. So it is given that the gradient of the straight line is PQ is -2/3. Point P lies on the y over x squared axis. Express y in terms of x. So we have here a linearized equation where y equals to mx plus c. So the y in this case, it is y over x squared. The gradient is given as -2/3 and x is given as x plus c. The y-intercept is c, so this is 0 and c lah here, this part here. So to find out what that value is, we are given one additional coordinate here already. So in other words, with this coordinate, we know that when x equals to -9, y over x squared equals to 8. Why I use y over x squared? Because this is the axis we are given. We follow the axis that we are given when we substitute. This is not y. This is y over x squared axis, right? So we substitute it into the equation. So it will be 8 equals to negative 2 over 3 times negative 9 plus c. 8 equals to 6 plus c. c equals to 2. So since we know c equals to 2, y over x squared, I think I better use a different color, otherwise you'll get a bit messy. Y over x squared equals to negative 2 over 3k plus 2. So making y the subject, we have this x, sorry. So we have y equals to negative 2 over 3 x cubed plus 2x squared, and this is done. So question 12. Diagram 3 shows coaches, 6 coaches of a train at an amusement park. So from here we have a family of 4 children with their parents take the train. Each of them will be sitting in different coaches. So find a different number of ways they can arrange themselves such that the father sits in the first coach while the mother sits in the last coach. So just arranging the coaches here. So the father is here, the mother is here, and their positions are fixed. So since their positions are fixed, means their children's position isn't fixed. So we care about what position they sit in. So in this case, we are going to use permutation. So there are 4p4. So because 4 is basically the number of seats available, and the 4 here represents the number of people to be seated. So since there are 4 seats and 4 people to be seated, we can simply do 4p4, and that will give us 24, is it? Yeah, 24. 24 ways. Right. So this is A done. So question B. Their parents and the youngest child must sit in 3 consecutive coaches. So now, the way that it's structured is a little bit different. Okay. So now the father and mother and the youngest child, I'll just say Y lah, right, must sit in one coach. So the rest of the children are kind of like outside here. Okay. So within this fixed category here, they can switch their positions as well. So I can call this as 3p3 because there are 3 seats and there are 3 people inside. Also, these 3 children here are also considered to be 3p3 because 3 children, 3 seats, and they can shift between one another. So this is considered to be one case in the arrangement. There are multiple cases in this because the 3 that are locked here is not necessarily in the first 3. They can also be here. Right? So since they can also be here, so I think I drew one extra line. Again, this will be 3p3 for the father, mother, and the youngest child, and again it will be 3p3 for the children that are outside. And you notice that this pattern will repeat itself in another case where I push the position a bit further, and for case 4 where I push this position at the edge. So there are 4 cases, but all of the ways you count is the same. So in other words, we can just take it as 3p3 times 3p3 multiplied by 4, because there are 4 cases in which this happens. So in other words, the final answer here will be 3p3 times 3p3 times 4. So there are 144 ways in which this can be arranged. Right? And this will be our final answer in this case. Right? So moving on to question 13. So table 2 shows the number of red and yellow marbles labeled with letter A and B in the box. So 2 marbles are drawn randomly from the box. Find the probability that the marbles are labeled with the same letter but with a different color. So we are looking for the probability of same letter but different color. So it means that we are looking for like probability of A red and A yellow, or we are looking for the probability of A yellow, A red. Notice that they will be the same thing later. So let me just write them down first before writing into equation. And the probability of blue red, blue yellow, and vice versa, blue yellow, blue red. So the probability of A red and A yellow in this case, now there is a little bit of an issue here because they didn't tell us whether we wanted with or without replacement, right? So the difference between with and without replacement is that if you have something with replacement, essentially means that you are going to take out the bit, take out one, and put it back in, right? So means that you take out one bit, you're going to put it back in before you take out the second bit, right? If we say without replacement, means that I'm just going to take out one and then take out the second one straight away. Or we say take out another one lah, and so on, right? So this changes the way that we count probability in this case, because the way that probability is counted is probability of we say when px is equals to the number of x over the ns, or the sample, the total. So x is what we want, s is the total number of items in that box or whatever, right? So in this case, if there are two ways to actually solve this question in this case. So we will start with the without replacement, because usually we will do without replacement. That's just what the questions normally ask most of the time. So when we do without replacement, so there are, for A rate alphabets, there are only two. So in this case it is 2 over, in this case total is 2 plus 6 plus 5 plus 4, that is 17. So 2 over 17. So without replacement means one bit is already taken out. So now is A yellow, which is 6. So there are 6 A yellows. However, there are only 16 bits left inside, right? Sorry, marbles left inside. So this is what happens when we count with replacement, right? So for AYAR, same thing, it will be 6 over 17 times 2 over 16. For BRBY, it would be 4 over 17 times 5 over 16. And BYBR would be 5 over 17 times 4 over 16. And notice that these two are actually kind of the same value, because 5 times 4, 4 times 5 is the same thing, right? So in other words, we can just make the calculation simpler by just taking 2 over 17 times 6 over 16 times 2, and this we can just do 4 over 17 times 5 over 16 times 2. So the value for these two are 3 over 34, and for the other one is 5 over 34. So therefore the probability of same letter, different color is simply 3 over 34 plus 5 over 34, which is 8 over 34, which is 4 over 17, right? So this is done. Now if you do it with replacement, okay, I will not count the final answer, but I'll just show you how a with replacement method works. So I'll do it in green color. So again, I'm just going to show just the method, not going to count the final answer. So just going to copy back all of the outcomes that we have. So ARAY in this case, it would be AR is 2 over 17. So with replacement means you're going to put back the bit. So now instead of 6 over 16, we're going to put 6 over 17. So you notice the probability is just the same. It's just that the total change. The total changes back to its original value, because you're actually putting it back into the box, right? So the only thing that changes in this case is the total number of beats when you take out the second beat, or marbles. Sorry, I keep thinking it's beats, marbles. Yeah. So this is with replacement lah. But I would take this because this is probably the closest to the answer, though the answer at the back is also incorrect from what I recall. So, but this is definitely correct in this case lah. They most likely forgot the second case where you can take AY and BY separately. Right. So moving on to the next question, question 14. So for question 14, find the value of 4 alpha times 16 alpha times 1 over 32 2 alpha. So for this question, we notice that all of these numbers can sort of reduce to a similar base, which is base 2. So if I reduce 4 to base 2 is 2 square, and if I reduce 16 to base 4 to base 2 is 2 power 4, and for 32 is 2 power 5. So from here, this reminds me of one of the in these laws where a power n is equals to AMN. That's why these two multiply one another. So from here I can apply it. So it's 2 alpha times 6 alpha times 1 over 10 alpha, right? So for this fraction here, I can actually apply one of the indices law where a negative m equals to 1 over am. I can convert it from here and inverse it so that it becomes negative. So it'll be 2 alpha times 6 alpha times 2 negative 10 alpha, right? Sorry, I said this is 6 alpha, this is supposed to be 8, my mistake. Because 4 times 2 is 8, I actually added it by accident. So from here, the last one is we have another indices law where am times an equals to am plus n. Right, we're going to add the powers if it's multiplied. So it will simply be 2 alpha plus 8 alpha plus negative 10 alpha. And then from here, you notice that we're going to end up with 2 to the power of 0, and this is equal to 1. Because any number to the power of 0 is equal to 1 in this case. So we have applied 4 indices laws in just this question alone. So moving on to question 15. Okay. So question 15, find the value of x which satisfies the following equation. 2 over log xxy plus 2 over log yxy plus 3 equals to 5x. So in this case, I'm just going to work with one of my log laws first, where log AB plus log AC equals to log ABC. So B and C multiply one another if they are added here. So I can actually convert it back to this form. So why I do that is because I want to try to I want to use this as a starting point to eliminate my terms. So log xxy would just be log xx plus log xy. So this will be log yx plus log yy. Then maybe I'll just subtract 3 on both sides to sort of move it to the other side. So I can just leave all the logs one side and all the numbers on the other side. So from here we have 2 over 1 plus log xy plus 2 over log yx plus 1 equals to 5x minus 3. So why is it 1 is because if your base number is same as the number in front, so we will just end up with 1. Alright. So here we will, if you want to combine these two terms together, we need to make the denominator the same. So in this case, I'm just going to cross multiply. So here I'm going to multiply by log yx plus 1, and here I'm going to multiply by log yx plus 1, and on the other side I'm going to multiply with 1 plus log xy, and I'm going to do the same here as well. Right, apologies for the writing, it's a bit small, yeah. So it will be 2 log yx plus 1 plus 2 plus 2 log xy over 1 plus log xy log yx plus 1 multiplied equals to 5x minus 3. Okay, so from here this would be 2, sorry, my mistake here, right? So from here we're gonna just simplify the top part, and we're gonna cross multiply the bottom. So we end up with, just gonna write it here because there's no space, 2 log yx plus 4 plus 2 log xy over, so 1 times log yx will be log yx, 1 times 1 will be 1, 1 times log yx again, log xy times log yx will be log xy log yx, so plus, this will be log xy. Is it? Yeah. So 1, let me just cross check, yeah, just to make sure. 1 times log yx will give us log yx. 1 times 1 provides us with 1. Log xy times log yx is log xy times log yx, and log xy times 1 will give us log xy. Okay. Now, special attention given to this one, because if you were to test this out on your calculator, like for example, we just use values, log 3 multiplied with log 2, you notice that you'll get the value 1. So once you test it out, so logically in this case, log xy log yx would be equal to 1 as well. So we can work on this by first simplifying the top, so it'd be 2 log yx plus 2 plus log xy over log yx plus 1. This is going to be 1 as well, so 1 plus 1 is 2 plus log xy. And this whole thing is going to be equals to 5x minus 3. And now you can see the top and bottom looks exactly the same. So here and here can cancel out because they are exactly the same. So it's 2 equals to 5x minus 3. And then we have 5 equals to 5x. Therefore, x is equals to 1 in this case. And this is solved. So moving on to question 16. So question 16, diagram 4 shows part of a circle with center O, radius 12. Given the length of arc AB is 4 pi cm, calculate the angle of AOB in radians. So the arc length given to us is SAB. So the arc length formula is r theta. So the radius is already given as 12 and the arc length is given as 4 pi. So leaving our answer in terms of pi, we will get 1 over 3 pi radian. Right, so this is question A done. So question B, area of shaded region, this part is actually called the area of segment. This part is called segment actually. So in other words, we are looking for the area of segment, which is also provided in a formula where half r square theta minus sine theta. So half, your radius is 12 square and your theta is 1 over 3 pi minus sine 1 over 3 pi. Right? So please take note to make sure that your calculator is in radian mode if you want to count this part of the bracket first. So 1 over 3 pi minus sine 1 over 3 pi times by 12 square divide by 2. So we end up with 13.044 cm square. And this is done. So moving on to 17. So for question 17, we have solved the equation cos 2 theta equals to cos theta for 0 less than theta less than equals to 2 pi. So here, cos 2 theta equals to cos theta. So cos 2 theta is a double angle. So there are a few identities that we can work with here, where cos 2 theta has 3, where we can say 2 cos square theta minus 1. Sorry, I wrote that a bit funny. 2 cos square theta minus 1. Or we can write it as 1 minus 2 sine square theta. Or we can write this as cos square theta minus sine square theta. Now, to make sure that only cos is in the function, we are going to use this. In the equation, we are going to use this. So from here we have 2 cos square theta minus 1 equals to cos theta. And 2 cos square theta minus cos theta minus 1 equals to 0. So by solving this quadratically, we have 2 cos theta minus 1 cos theta plus 1 equals to 0. Sorry, it should be terbalik. Yeah. So from here, we have, when we solve them individually, it will be 2 cos theta equals to negative 1, cos theta equals to negative half. Here cos theta equals to 1, and then we can start solving it. So by solving the negative part first, if you insert this into your calculator straight away, you'll notice that you only get one answer. Now, we are usually supposed to get two answers because of what we understand from the unit circle, right? So the first, second, third, and fourth quadrant, right? Sine, cos, and tangent are positive in certain areas. So we usually remember them as ASTC, or add sugar to coffee, right? So A stands for all, S stands for sine, T stands for tangent, C stands for cos. Means that in the first quadrant, everything is positive. Sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant here. So by understanding this, when we see cos theta equals negative half, we understand that cos is currently negative. Therefore, our answer would be in the second and third quadrant because cos is only positive in the fourth and first quadrant, right? So our answer will be in the second and third quadrant. And the formula we have for the second, third, and fourth quadrant is 180 minus theta, 180 plus theta, and 360 minus theta in this case, right? So this theta is actually the basic angle, or the angle in the first quadrant. So we have to find the angle in the first quadrant first, cos alpha equals to half, so alpha is equals to 60 degrees in this case. So from here we can apply the answers in the second and third quadrant, where it's 180 minus 60 and 180 plus 60. So we have the answer as 120 degrees and 240 degrees. So they want our answers in pi because they gave us the range in pi, the domain in pi. So it's 120 times pi divide 180. So yeah, just to let you know, the conversion to convert a degree to radian, we take theta times pi over 180. This is just for you to know. So this is going to be 2 over 3 pi, and this will be 4 over 3 pi. Okay, so the next one, cos theta equals to 1. So when we shift cos theta, we are going to get the basic angle straight away. Cos is positive in the first and fourth quadrant. In this case, this is the first and fourth quadrant. So when cos theta is 1, we have 0 and 0 degrees and 360 minus 0 degrees. So that's just 0 and 360. So in other words, when we convert it to radian, it will be 0 and 2 pi. So our final answer is 2 over 3 pi, 4 over 3 pi, 0 and 2 pi. So we have 4 answers in this case. So moving on. So question 18, diagram 5 shows a probability distribution curve for a random variable x, where x approximates normally, to mean and y. So the way that this is written, so x is normally distributed and they put mean and they put y like this. The normal way to write it is that this is supposed to be the mean and this is supposed to be the variance. So they actually provided the variance to us, which is y in this case, right? So they said that given the z-score of m is k, express y in terms of m and n of k. So here, this is just a probability distribution graph for x. This is not the z-score. Now, if you notice, the difference between this and the z-score is that for the z-score, it is usually written like this, and we write z here, and then this is considered to be 0, right? So why is z 0 at this point here? Because this part is when we have the mean, right? Because according to our formula, z equals to x minus mu over standard deviation. If your x and your mean is the same, means that your z-score will be 0. Therefore, at this part, your x is equals to your mean, right? So therefore, in this case, our mean is given as 5. Okay, m is just a value that is greater than 5, but we don't actually know what m is in this case. So we can denote that as our x, right? So by using the formula, they said that given the z-score of m is k, so that when x is when your x is m, your z-score is k. So we can know that z is equals to k as well. So we have so many clues that given to us already. So we have z equals to x minus mean over standard deviation. So z is k, x is m, mean is 5, and standard deviation is the variance is given to us as y. Therefore, the standard deviation is root of y. Sorry. So by swapping places, because we need to make y the subject, so root of y equals to m minus 5 over k. So squaring both sides, y equals to m minus 5 over k whole thing square. So this is done. Okay. So moving on to question 19. So question 19, diagram 6 shows a graph of probability distribution of random variable x such that x approximates x is distributed binomially 3p. So when we write like this, the stuff that we usually write in the bracket is that here is the number of trials, the left side is the number of trials, and the right side is the probability of success, right? Of a successful trial in this case. So they want B in terms of A. So they have provided to us different values when x equals 0, 1, 2, and 3 up to the third attempt, 3 trials. And they gave us a probability of success for each, right? Or the probability to get x number of trials. So that means when the probability of getting 0 successes in this case would be 3b squared. The probability of getting 1 success is 3 over 7. The probability of getting 2 successes is A, and the probability of getting 3 successes is 3b squared. However, we understand that probably the total probability of any situation, total probability in any situation is equals to 1. Therefore, we can say that your probability when you have zero successes added with your probability with 1 success, 2 success, and 3 success should equal to 1. So in this case, we have probability of when for 0 successes is 3b squared, 1 success is 3 over 7, 2 success is A, and 3 success is 3b squared. So all of this should equal to 1. So in this case, express B in terms of A, we're going to make B the subject here. So 6b squared equals to 1 minus 3 over 7 minus A. 6b squared equals to 4 over 7 minus A. Then B squared equals to 2 over 21 minus A over 6. So B is equals to square root of plus minus 2 over 21 minus A over 6. Right, so this is B in terms of A, done. So for question B, find the probability of x greater equals to 1 and give your answer in terms of B. So probability of x greater or equals to 1 is technically you have to add up x equals to 1, x equals to 2, and x equals to 3 together. So to make this a bit faster, I can instead write this as a complement. So I can say that the probability, since we had this equation here earlier, right? So the probability of x equals to 1, x equals to 2, x equals to 3 is simply just 1 minus probability x equals 0 by just bringing this to the other side, right? So this is what I mean by the complement. So therefore, the probability of x greater equals to 1 is equals to just 1 minus probability of x equals to 0. So why I do this also is because I need my answer only in B. If I were to use any of these 3, I will definitely get an A inside already, right? So to avoid the A, I will get 1 minus probability of when x equals to 0. So it will be 1 minus 3b squared in this case. So this is done. So question 20. So for question 20, diagram 7 shows a straight line that passes through point M, negative 2, 3, and makes an angle alpha from the positive x-axis. Using cos alpha equals negative 12 over 13, find the equation of the straight line AB. So once again, we are given a concept for unit circle here, right? Now, the question about this is that most students ask, how come I can just say this alpha and assume this is theta, and then I can say that cos theta equals to 12 over 13, right? Now, this assumption that we have is not really an assumption, it is logic, right? Based on what we know in unit circles. So now, when we think about it like this, right? This is an obtuse angle. An obtuse angle is basically an angle in the second quadrant. It's between 90 and 180, right? So we already mentioned earlier that cos is negative in this quadrant. Now, if you've ever wondered why this is the case, right, I'll do a short explanation here. Now, in our 4 quadrants here, right, you notice that all of these, every single value in the first quadrant has a corresponding value in the second quadrant that is similar. So let's just take, for example, theta. So I'll say that sine 30, I'll just use an experiment here. I'll take cos 30 and tangent 30. Right? So sine 30 in this case is half. Cos 30, if not mistaken, is root 3 over 2. Yep. And tangent 30 is root 3 over 3, I think. Yeah. Now, since we know these 3 values already, I can use logic to find out what is the corresponding value on the second, third, and fourth quadrant. So if you try in your calculator, sine 150 is also equals to half. Cos 150, however, is going to be negative root 3 over 2, and tangent 150 is going to be negative root 3 over 3. And again, moving on, here I'm going to get sine 210, which is equals to half, sine cos 210, which is going to be, sorry, negative half, yeah, in this case. This is going to be negative root 3 over 2. However, tangent 210 is going to be root 3 over 3. And lastly, sine 330 is going to be negative half, cos 330 is going to be negative root 3 over 2, and tangent 330 is going to be negative root 3 over 3. So by calculating all of these values, this is supposed to be positive, yeah, sorry. By calculating all of these values in calculator, you notice that I can keep getting the same answer, but it's just that different quadrant, different symbol. So that's why we have the ASTC, right? All is positive in the first quadrant, sine is positive in the second quadrant, tangent is positive in the third, cos is positive in the fourth, right? And you probably be wondering, how did I count all of these values so quickly, right? Or how did I know what the values were without even using the calculator? Now, it's because of the formulas that I told you about earlier, which was 180 minus theta, 180 plus theta, and 360 minus theta. And then you'll be curious, where in the world did this even come from in the first place, right? And like I said again, this is logic, right? So we think about it like this. When this is 30, if I were to reflect this line on the other side, this would be 30 as well, right? So in other words, the sine of 30 would be similar to the sine of 150, because I am actually using the angle, getting back the same angle, but using a reflection of the line here. So that's why sine 150 is the same as sine 30. Or in other words, to find the angle in the first quadrant that's the same in the second quadrant, we do 180 minus theta. Because if you look at it, I did 180 minus 30 in this case to get the 150 here, right? That's for the first quadrant, for the second quadrant. The third quadrant, if I were to extend it, you see, if I extend this line all the way down, I get a reflection here, right? And now my total angle, here I know it's 180, and this is 30. So this is where the 180 plus 30 comes from, and I get 210 degrees, right? And for the last quadrant, right, this is 30 degrees. Reflected on the x-axis, this is also 30 degrees. So the angle generated here is basically 360 minus 30, which is eventually 330 degrees, right? So all of this is actually based on logic, right, in this case. So this is just a brief explanation of how we can assume that because the obtuse version is negative, we can assume that the acute version is positive, because in the first quadrant, all values from 0 to 90 is positive, right? We know that the value we get is going to be positive in the end of the day, right? So we can use that assumption here. So I'm just going to erase all of this because it's not really relevant. This is just for me to explain to you what is actually going on here. Okay. Now, for question, so continuing on, we have a certain value already here, and technically here this is a right angle triangle. So I'm just going to take out that triangle here. Now, this is going to be theta, and this is negative 2, 3 m, and this is I don't know what's the coordinate here, but I can just call it x and 0 lah, right? Now, if we apply cos theta equals 12, 13, cos theta is also adjacent over hypotenuse. So it means that this is going to be 12, and this is going to be 13, and we use Pythagoras theorem, this is going to be 5. However, if you notice, this is actually incorrect, because if according to the triangle, this length here is actually supposed to be 3, right? But according to my trigonometric function, it's supposed to be 5. So we have to follow what the question gave us. So it means we have to scale 5 down to 3. So in this case, I'm just going to do times 3 over 5, and then I can get 3 here. So all of these quantities needs to be multiplied by 3 over 5 to scale it down. So now my hypotenuse is 39 over 5 and my adjacent is 36 over 5. Right? So this is important because we need to follow the scale so that we can actually get the correct coordinate in this case. So they want us to find the equation of straight line AB, so I should find the coordinate of this first now. So we know that this x coordinate here is -2 and this coordinate here is x, and we know the distance between them is 36 over 5. Now if you can't see this very clearly, it's always good to draw an example to see it yourself. So let's just draw like this. I'm going to call this 2, I'm going to call this 6, and we know that the distance is obviously 4. But the question is, how do I get 4? I actually take this, subtract with this, and then I can get 4. 6 minus 2 equals to 4, obviously. So in other words, I can take from here as x minus -2 equals to 36 over 5. So x plus 2 equals to 36 over 5. So x is 36 over 5 minus 2 in this case. So I'm going to get 26 over 5. So that is my x coordinate. So from there, I can find the gradient of the line. So M line, or we say MAB lah, right? Because now the coordinate here is -2, 3, and this is now 26 over 5, 0. So we have 3 minus 0 over -2 minus 26 over 5. So by just doing that on the calculator, so I'll get -5 over 12 as my gradient. So for the equation of the line, I will get y equals to mx plus c. So to find c, I'll just insert back the coordinate here. When x equals -2, y equals to 3. So 3 equals to -5 over 12 times -2 plus c. So your c is just going to be -5 times -2 divide 12. 3 minus, so it's 13 over 6. So my final answer here would be y equals to -5 over 12x plus 13 over 6 in this case. So this is question 20 complete. So moving on to question 21. Oops. So for question 21, given points -2, 2, B0, 4, 3, 7 are on a straight line. Point B divides the line segment AC, AB equals to KAC. So we have a line segment here. So I'm just going to draw it. So this is A, B, and C. So they told us that AB equals to KAC. So according to, if I want to make a ratio out of it, I need to put the AB and AC on one side. So I'll get AB ratio AC as K ratio 1. So how I did this is basically, I divide both sides by AC, right? And then I can actually get the AB over AC lah, in this case. So I can get the ratio here. So AB ratio AC is K ratio 1. So this is K. So the whole ratio here is 1. So obviously here would just be 1 minus K lah. So the coordinates is -2, 2, 0, 4, 3, 7. So from here we can apply the segment formula. So the segment formula is very simply just given 3 points. This is x1, y1, xy, x2, y2. This is m and n. So the cross is basically you cross the segments here, multiplying them. So it's nx1 plus mx2 over m plus n equals to x. And you do the same for y as well. Means you take this value, multiply by the x value, take this value, multiply by x value, divided by the sum of the segments. So it's equals to the coordinate in the middle here. And we do the same for y as well. So in this case, they want us to find value of k. So we can just use either x or y. In this case, I'll just use x. So k times 3 plus 1 minus k times -2 over k plus k minus 1 equals to here 0. So k times 3 is 3k. 1 times negative 2 is negative 2, and negative k times negative 2 is 2k, over k plus k is oh sorry, it's 1 minus k, not k minus 1, my mistake. So here is going to be just 1. So 3k minus 2 plus 2k equals to 0. So 3k plus 2k is 5k equals to 2. So k is equals to 2 over 5. So from here I already know that this is going to be 2 over 5, and 1 minus k is just 3 over 5 here. So AB ratio BC is 2 over 5 ratio 3 over 5. So ratios should not have fractions in them, so multiply both by 5, you have 2 ratio 3. And this will be our final answer. So carrying on to question 22. So question 22, r equals to 3n minus 2, 5, s equals to m minus 1, 15. Express m in terms of m such that 4r plus s is parallel to the y-axis. So let's find out what 4r plus s is first. So we just need to multiply in what we have. So it's just 4, 3n minus 2, 5, plus s is m minus 1, 15. So it's just 12n minus 8, 20, plus m minus 1, 15. So we have 12n minus 8 plus m minus 1, 20 plus 15 here. Right. So this is going to be 12n plus m minus 9, 35. So this is the vector that we're provided. So just take note that in this form, the number on top usually represents the x vector, right? Or the vector in the direction of x, right? Sometimes denoted as I. So the number at the bottom is the y vector, or the vector in the direction of y, or sometimes known as the j vector, right? So they told us that this vector is parallel to the y-axis. So what does it mean to be parallel to the y-axis? Means that this is the y-axis here. Parallel to the y-axis means the vector is moving in this direction, right? So it means that the vector only moves from top to bottom, right? Means it doesn't move from left to right. It does not move from left to right at all. So in other words, this vector is basically 0, y. Because x doesn't move, it doesn't move in the x direction, it only moves in the y direction. Therefore, we can make an equation where 12m plus m minus 9 is equal to 0 in this case. So 12m plus m minus 9 equals to 0. So from here, they want us to make m the subject. So m is equals to 9 minus 12n. This is solved. Okay. So question 23. So for question 23, sailboat is situated 450 meters from jetty Q. Sailboat is situated from 200 meters from jetty Q. By using U to represent 50 in, okay, it's a bit long. So I'm just going to write down what I have first. So A, B, Q. So here is 450 meters and here is 200 meters. So using U to represent 50 meters in QB, so QB is in this direction. V, so 50 meters in QB means that U equals to 50 meters. Therefore, 200 meters is just, so here times 4, here times 4. So 4U equals to 200 meters. Therefore, the vector in this direction is 4U. Right. So the other one is V represent 100 meters in QA. So QA is in this direction. So V is 100 meters. So times 4.5 times 4.5, we will get 4.5 V equals to 450 meters. So the vector here is 4.5 V. So here we have express AB in terms of UV. So AB is here. So to go from A to B means you have to go from A to Q and then Q to B. So AB equals to AQ plus QB. So AQ is negative 4.5 V and QB is 4U. And this is done for question A. So question B, it is given that sailboat A and sailboat B have the same magnitude of 45 km per hour. If the magnitude of sailboat A is 26I minus kj km per hour, find the value of k to the nearest integer where k is more than 0. Now, they gave the magnitude of the sailboat A is 26I minus kj km per hour, but actually we did this is actually a vector, so they haven't actually given us the magnitude yet. This is the vector of A in the first place, so we can find the magnitude of A by simply using Pythagoras theorem. 26 square plus negative k square square root, so it's going to be 67 square root of 676 plus k square. Right, so this magnitude is the same as this magnitude because they told us that the magnitude of sailboat A is also 45 km per hour. So in other words, we can say that this is equals to 45 km per hour. So 676 plus k square equals to 45 square when you square both sides. So it's 2025. So k square equals to 2025 minus 676, that is 1349. So square rooting both sides will be k equals to plus minus 36.7. So since they say k is greater than 0 and they want the nearest integer, therefore k is equals to 37, positive in this case. Okay, moving on to 24. Given the quadratic function fx equals to x squared minus 2x plus p, where p is a constant, is always greater than 3, find the smallest integer of p. So they say that p is a constant always greater than 3. Oh, sorry. Right? In other words, their p in this case is actually the y-intercept, if you notice. So in this graph, this is a minimum graph. So they are actually referring to the graph that looks something like this, right? It's always above 3, greater than 3, right? So to find out what is the smallest integer, we need to actually convert this into a vertex form, so that we can actually find what is the minimum point or the smallest value that p can be in this case, right? So we're going to actually use completing the square to convert it to vertex form. So we have x squared minus 2x plus, so this will be negative 2 over 2 square minus negative 2 over 2 square plus p. So x minus 1 square minus 1 plus p. So according to the vertex form, this is the x coordinate of the minimum point, or we call it as the axis of symmetry sometimes. And this part here is the y coordinate of the minimum point or maximum point, right? In this case, minimum point cause the coefficient in front of x squared is 1, positive 1. Sometimes you call this the minimum value as well, right? So in this case, it is always greater than 3. So we can say that we are referring to this one here, where we say negative 1 plus p must be bigger than 3. Therefore, p is greater than 4. Therefore, the smallest value for p is 5 in this case. So this is done. So the last question, question 25. So the equation of the curve y equals 2x squared plus ax plus 12 can be expressed in this form, where a and b are constants. Find a and b. So once again, we're going to convert into vertex form. So y equals to 2x squared plus ax plus 12. So before we start, we need to make sure the coefficient in front of x squared is 1. So just dividing everything by 2. So y equals to x squared plus a over 2x plus a over 4 square minus a over 4 square plus 6. So y equals to 2 x plus a over 4 minus a square over 16 plus 6. So multiplying the 2 back inside. So do not multiply the 2 into the square because it doesn't work in that way. When you have to actually expand this first before you multiply 2, but we don't need to do that. Oops. Minus a square over 8 plus 12. So now we can compare with what we are given. So we were given that 2x minus 3 square plus b is equivalent to what I've calculated here. So from here we can make a comparison. So x plus a minus a over 4 and this, we can compare it. Therefore, it would be a over 4 equals to negative 3 in this case. So a is equals to negative 12. So by comparing b, negative a square over 8 plus 12 equals to b. So it's negative 12 square over 8 plus 12 equals to b. Here, please take note, do not make the negatives positive yet because we have to square first. Right, that is the order of operations. So it's 144 over 8 plus 12 equals to b. So 144 over 8 is 18 plus 12 equals to b. So b is negative 6 in this case. Right. So question B, find the minimum value of y. So the minimum value of y in this case would be simply here. Right? Because like I mentioned earlier, this is the minimum. This in the vertex form, this is considered to be the minimum value. Therefore, we can just say mean value equals to negative 6. And this is done. So this is all. That is all for the paper 1, SBP 2020 paper 1 for additional mathematics. So if you guys have any questions or you notice any mistakes that I made during my calculations or workings, please let me know in the comments. I'll try to correct them immediately. And also if you have any more questions or you want me to tackle a specific question or specific paper for the SPM trials, please let me know. And I hope to see you guys in the next video.